Wind turbine. Wind energy has long been used as a source of mechanical power. The familiar four-bladed windmill of Holland, England, and the Greek island have been used for centuries to pump water, grind grain, and saw wood. Modern research concentrated on the ability of wind turbine to generate electric power. Koppel stressed the potential for the propeller-type machine. Spera give a detailed discussion of the technical and economical feasibility of large-scale electric power generation by wind. There are various applications. Some examples of wind turbine design are available in the literature. The first subsection in this chapter is idealized wind turbine theory. The ideal frictionless efficiency of a propeller windmill was predicted frictionless efficiency of a propeller was predicted by A-type bits using the simulation shown in this picture. The propeller is represented by an actuated disc which created, let me write actuator, which created across the propeller plane a pressure discontinuity of area A, as shown here, and local velocity V. Velocity and area. The wind is represented by a stream tube of approach velocity V1, approach wind V1 and P infinity atmosphere, and slower downstream wave velocity V2. Downstream V2, the pressure rises to B. PB just before the desk. The desk and drops to PA just at. Drops to PA after the disk. Returning to free stream pressure in the far wake. To hold problem rigid when it extracted energy from the wire, there must be a leftward force F on its support as shown. A control value of horizontal momentum relation applied between section 1 and 2. In the x direction we have minus F M dot V second minus V1. A similar relation for a control volume just before and after the disk. A and B before and after the disk is minus F plus equating these two years, the problem force should be equals to F so now we have a relation F as you weigh ideal flow, the pressure can be found by applying the incompressible Bernoulli relation up to the disk. From A to second subtracting these and noting that M dot equals to rho VA, we can obtain this relation P minus PA and V equals to continuity and momentum does require that the velocity V through the disk equals to average of weight and the form rate as shown in this relation. Finally, the power extracted to the disk can be written in terms of V1 and V2 by combining the equations above. We have P, F, V. V from this relation, and also we have F here. Now we can write the relation for the power. Rho A V square multiplied to two relation for the power. For a given wide speed V1, we can find the maximum possible power by differentiate P with respect to V2 and setting equal to 0. The result is P max V2 equals to 0. We can obtain the differentiating P with respect to V2 and equals to 0. The P max can be obtained the maximum power of a wide turbine. The maximum available power to propeller is the mass flow through the propeller times the total kinetic energy. The maximum P available or equals to the maximum possible efficiency of an ideal frictionless wide turbine is usually stated in terms of power coefficient, which is Cp P on 1 second over AV1. This is the maximum available power, and this is the power of output power. Can be calculated from the previous relation. Equation can the power coefficient, maximum power coefficient is it is called the Betz number and serves as an ideal between to compare the actual performance of real wide beam. The Betz number, this is called the serves as the ideal between compared to actual performance of wide beam. This is the end of the chapter 11 and also the end of the fluid mechanics from front and right. We studied about 828 pages. a good time.